Can you spot the difference which one was made by a factory and which one is homemade? Well, obviously this one is an Arduino Uno and this was made in a factory, but this is also a quite professional PCB. So today I want to show you how to pass from this, which is a blank copper PCB, to this, which is a homemade but quite professional PCB for an Arduino Uno. It has 0.2mm tracks, it has solder mask, it has all the pads, it has a very small clearance and so on. And I will do that using a fiber laser machine like this one. So let me show you all the process that I went through to pass from this to this and show you how to make homemade PCBs that are quite professional. That being said, let's get started. Hey guys, PCBWay is sponsoring this video, and let me just tell about their services. For example, look how awesome their prototyping PCBs are. And you can get these for only $5. They are so professional and they will make your project work a lot better. And to order such PCBs, you only need a few minutes on their website, where you can select any configuration that you want for your boards. Along with that, you can also order the SMD stencil for soldering the components using solder paste. And you can also use their services for flexible PCBs and create some unique projects. And if you want to make your project start to finish, you can get the PCBs assembled together with the mold injected part, or maybe 3D printed, metal parts, or other CNC services, all with PCBWay. What's up my friends, welcome back. So let's see how to pass from this to this. But first, some safety. This machine works with a very strong laser, and the worst of all is transparent, you can't see it. So make sure that you wear some proper glasses for this laser, and also even maybe close this inside of a case or place the shield that the machine gives you in order to protect yourself. And then make sure that you use some sort of mask, because the fumes that get out of here from the PCBs are quite toxic, and maybe if you have a fume extractor, it will be even better. So add a fume extractor to get out that smoke. And maybe as extra, wear some gloves, because the dust that this will create also could be a little bit toxic. Okay guys, so step number one is to check your PCB for any kind of error. For example, the first error that you could encounter is that the PCB is not flat. Now, having in mind that we will use this laser engraver or laser cutter to make this PCB, is not like the CNC machine where you can test for the level and then subtract that errors into the CNC software that you are using. Because in this case, we have always the same height, so you must make sure that the PCB is flat. So there are some PCBs that when you place it on the table, it will wobble. You can use that, or at least not like that. You have to first flatten the PCB to make sure that each point on the PCB will be at the same height, because the focus for the laser will change otherwise. So that's the first step. But also inside of this first step, you can also check for errors. For example, I bought these PCBs here that come each one in one bag. So it's protected a little bit by this plastic bag, as you can see here. But these other ones that I've used for the test come all the PCBs inside of the same bag. So they can rub in between each other, and some of the PCBs you will see that some copper areas are missing. I'll try to place some pictures on the screen with my microscope. So we'll have some very small dots without copper. So if your circuit will pass exactly on that area and you don't have copper, well, that will be an open circuit and the PCB won't work, because you don't have a copper track on that position. So make sure that your copper is okay. As you can see here, we can see some small dots. I'll try to place a close-up of this PCB. So this PCB can be used. So make sure that it's okay, it's flat, and also that all the copper area is intact. And the third part for this first step will also be to check the thickness. Because when you buy the PCB, it will specify how much copper it has on top, because the thicker is the copper layer, the more power we need for our machine. So maybe if you don't have the same PCB as I do, you will need more power. And if you have less, actually you can have less, because this is the least amount of copper that you can have for a PCB. But if you have more copper on your board, you'll have to use maybe more passes or maybe more power. Okay, and the second step is to clean the PCB and prepare it for engraving. Now, why you have to clean it? Well, because inside of the factory and for shipping, this PCB might be filled with maybe dust or something like oil. That's why I usually use some alcohol and also something like a kitchen sponge and clean it well. And also have in mind that if you leave this outside, even if this is copper, it will still oxidize or even rust. The copper rust is something like a green color, but as you can see here, this is a new PCB, and this is a PCB that's been outside for like 2 weeks. And even if this is for testing, but as you can see, the color of the copper it's a little bit brownish, and that's oxide, and that will interfere with you when you want to cut it with the laser. So make sure that you clean that, maybe with some very fine sandpaper, and then with alcohol, and make sure that the PCB is clean and ready for the engraving process. Oh, and by the way, also maybe cut it to size. As you can see, I'm using this size of the PCBs, but you can get it like this or even bigger. Have in mind that my machine will only work with 110 by 110 millimeters or 200 by 200. So in this case, I will work with this, and this will be the size that I'm using. And having a bigger PCB will also mean more area for error and more area for movement. So maybe cut it to size to be close to the PCB that you want to make. Okay, and the third step in my case was to make a lot of tests, because this was the first time that I was using this machine to create PCBs, so I wasn't sure about the power, about how many loops I have to make, about the frequency of the laser, because this is a fiber laser, so you can also change the frequency. So my tests were for power, speed and frequency, and also for cutting the copper. So I've made a bunch of tests for removing the solder mask, for engraving just the tracks, for cutting the entire board, for removing the pads for the solder paste, and so on. So once you have all these tests, you write the results on a piece of paper, and then you can create your PCB with exactly the settings that you need for the speed, the loops, the frequency, and the power. So in my case, the first test that I've made was of speed and power, because with that you will find the exact power that you need in order to cut through the copper. Because once you're able to cut, you can always dim the power and just only engrave a little bit. At the same time, you can also make maybe power and frequency, because the frequency will also affect how much of the copper you remove. So in my case, the best frequency for copper is 37 kilohertz, and that's the frequency I've always used for all the tests, 37 kilohertz. But then for the power and speed, depending of the job that I want to do. For example, for the engraving, I'm placing a full power, but I increase the speed a lot. But for cutting the outline of the board, also full power, but I lower the speed at almost 20 or 30 millimeters per second, and that will cut the board. If you only want to clean a little bit the pads, the SMD pads, you can lower the power. You will see in this video what I'm talking about and all the settings that I've used. And this will be the test that you should make. Power, speed and frequency for cutting the copper. Then for the copper tracks, you have to test power and speed, how many loops around the tracks in order to engrave just a little bit and also add the clearance, and how much overlap of each loop. And the overlap, I mean, if the laser is passing here, the first loop, the laser will pass with how much overlap in between. Usually it's 50 or 60%. I've used 60%, which is the best results for me, but you can test it out in the CAD software and see how much overlap to add in between the loops. And then you have to see how to remove the pads for the solder mask, and also how to create the silk layer, how to cut the board, how to drill the board, which is the most difficult part for this project, and yes, how to make the solder mask. Those will be the tests that you should make, and write the values and the results on a piece of paper, and then use it for the final PCB. Okay guys, before we go through all the steps that you have to follow in order to make a PCB, let me just show you some of the tests that I've made in order for you to make the same. This was the first test, and as you can see, I have these graphs here, and this is frequency versus power and speed versus power. In order to find how much power I need in order to put and how much speed in order to remove the layer of the copper, because that's what's important for me, because I only want to remove the layer, and then at the end I want to cut the board. Once I knew that, I've selected a frequency of 37 kilohertz, and I start making tests, as you can see here, for the outline of the tracks. So these are all the tests, changing the speed and the frequency, changing the loops, and also the overlap of each design. And this is just one of the PCB, because here I have a lot more, and then I have a bigger one which is back there with a lot of tests, and I find the settings for speed, power and frequency in order to cut the outline of the tracks, which is probably the most important part for this project, because you have to find the perfect clearance and also the thickness of the tracks, which in my case I went down to 0.2 millimeter tracks and a clearance of 0.15 millimeters. Now that I know how to remove the copper and also how to create the tracks, I've made some tests with some solder mask. This here is only green solder mask, and this is first red and then green. I wanted white and green, but I didn't receive the white yet. By the way, these are the solder masks that I'm using. I have the red one, the green one, and the blue one. Also have in mind that probably the longest process that you will make for this project is the solder mask, because for cutting the board, actually you can make it in like with the tracks, with cutting the outline, flipping the board, make the both layers, probably a sum of maybe 5 or 6 minutes, because this is very fast. But applying the resin and let it cure it will take like half an hour. Actually, have in mind that the green one takes around 25 to 30 minutes to cure. The white one will take just 5 minutes, the blue one 20 minutes, and the red one something like 15 minutes. So depending on the color that you are using, you will have to wait more or less. But that's just time that you place the UV light and you can leave and do other stuff. So that's not the time that you will lose. Just place the PCB below UV light, leave it there for half an hour and come back later. So once I have the resin placed on the PCB and cured, I've made some tests for power and speed once again and see how much power I need to put in order to remove just a small layer of the solder mask and fully remove it. And in this case, since I have two colors, how much power I have to put in order to remove only the green mask or the red mask or both masks at the same time. Because like that you can make multiple colors, so you can make the PCB be green and the text on the PCB to be red. So that's something that I've tried. So make this test as well. This is the third test. And for the fourth test, I've tried drilling, and this is a process that maybe is the one that worst I've got, because it's a little bit difficult to drill when the PCB is placed against the machine. That's why for the next time that I will try this, I want to make some sort of 3D support that will keep the PCB in mid-air so the laser could pass. Because you see, when the laser passes on the other side, it bubbles up on the bottom layer when it pulverizes the copper, and that makes the PCB move a little bit upwards and downwards. And also, since this is a layer, it will have a cone shape, so the hole here is not the same size as the hole on the other side. So I've tried to manage that, and the best option that I find is to just engrave the top side just halfway, flip it, and then engrave it once again halfway, and that will make a drill to the other side, and the hole here it will be perfect. I try to place a close-up look on this, and the holes are very good. So this is the fourth test for drilling the PCB, which is probably also the most important part, making the tracks and drilling. And the final test was how much power and speed I have to put in order to cut the PCB, the outline. And this will probably take you like the most like 1 minute or even 2 minutes to fully cut it, because in my case I have made 5 loops of 30 millimeters per second and 100% power, and that will cut the PCB to the other side. And that's it. Now that you have the tests, we can pass to the steps that you have to follow in order to make a one PCB like this. Okay, so now we'll go through the steps one by one, but then I will make the design in EasyCAD and show you how to prepare the design for the machine. So the steps will go like this. By the way, between each step you have to clean the board, because this will make a mess and some very fine dust of copper. So clean the board between each step. The first step was to just fix the board in place. So you get your board, something like this one. You cut it to size, and then on the machine you preview the outline of the board, you fix it more or less, and in my case I've used some scotch tape to place it, to glue it to the machine so it won't move. So that's the first step. Quite easy, right? Then the second step is to cut the outline that we've made for the position. You will see that when we make the design, we have the outline of the PCB, which for example is this one, but then you have another outline around the PCB, and we use that with a specific shape, because this is not a CNC machine and we can't actually center the board for when we flip it, because this is a laser machine. So what I've done is to make this sort of shape. So what we'll do later is to cut the PCB like this and then use some cardboard. We cut the cardboard and then we can fit our PCB inside of that cutout of the cardboard. Like that we ensure that we are always in the same spot even when we flip the board. You will see when I will show you the tests. So the second step is to cut the outline of the PCB for positioning. Not the outline of the PCB itself, but the positioning outline that we'll make in the software in a few minutes. Then we create the top layer tracks. So use the settings that you have for your tests and create the top layer tracks, and that's it. That's the third step. So as I've told you, the fourth step is to make the drills, but make the drills just halfway. But for the first tests, this is where I changed it a little bit, because for the fourth step, I first made the drills full way, and that's not recommended, because actually I've made the holes and then I've applied the UV mask, and the UV mask got inside of the hole, so I have to apply the holes to make the holes once again to remove the mask that is inside of the holes. So that's not recommended. So for the fourth step it will be to apply the solder mask, and for the fifth step is to make the holes just halfway, and then when you flip it, make the holes all the way. So fourth step, it will be apply solder mask and cure it, and fifth step, it will be to make the drills, just halfway. Okay, so for step 6, it will be to remove the solder mask from the pads that you don't want it. So for example, from the SMD pads or for each of the vias and so on. So just get your solder paste design and remove the solder from the pads. So you'll have your tracks, your solder mask, and then the pads, which will be clean. And for the step 7, it will be maybe to create your silk layer. In this case, I've tried to make it just with one color and it didn't get good results. But in my case, if I would have the white silk layer, the white solder mask and the green solder mask or any other color, I could make different colors for the silk layer. So in my case, the results weren't that good, so I don't recommend it to start it with. If you are more good with the results, then you can try the silk layer as well. Okay, so the step 8 is very important because here is where we flip the PCB. So you have to flip the PCB in real life, so you get your PCB and flip it, but you also have to flip the design. I will show you how to do that in just a moment. And also make sure that if you flip it horizontally, you flip it in the software as well horizontally. And if you flip it vertically, you flip it vertically as well in the software. And now, just take the outline perimeter and for the next step, cut it inside of a cardboard. And then make sure that the cardboard is glued to the machine and the cardboard is very fine, it's not just it's not a thick cardboard. And then you can place your PCB and place it there. In that way you will make sure that it will be centered with all the vias, with all the tracks and so on. So it will be centered with the other layer that we have just cut it. So for the step 8 is to flip the board, create the bottom tracks, and then for the step 9 is once again apply the solder mask, and step 10 is remove once again the solder mask for the bottom layer. For step 11 it will be to drill the holes all the way because we have the holes from the bottom side and now we have the holes from the top side and that they will merge together. And for the step 12 is to add the bottom silk layer if you want to add the silk layer. And step 13 is to cut the entire board. So from the cutout that we've made for positioning, we cut the actual PCB out. And that will be it. These are just 13 steps that you have to follow. Fix the board in place, cut the positioning outline, create the top layer tracks, make the drills halfway, and this is switch because if you remember is apply the solder mask and then make the drills halfway, remove the mask from the pads, create the silk layer in case that you have one, flip the board and make the bottom layer tracks, apply the solder mask once again and expose once again with UV light, remove the mask for the pads, drill the holes all the way, add the bottom silk layer if you have one, and finally cut the outline of the board. 13 steps, and if you know what you're doing and you have all the tests, you can finish this in under 10 minutes without counting exposing the UV light, which will take like half an hour. Just for the actual using the machine, 7 minutes maybe top. Okay guys, so now we are into the software that we are using to create the PCBs, and there are a few steps that you have to make before you create the Gerbers, and then we pass to FlatCam and create the CAD design for the machine, for the laser machine. So the first step is to add that positioning outline that I've told you about. So it will be, let me just make a Ctrl Z here. So as you can see, this will be the outline of my PCB, but then I've created this other outline with a strange shape. So it doesn't have to be exactly this shape, but it has to have some corners, because the more corners you have, the better it will be positioned, because if this will be round like this one, for example, it's very easy to move around. So you have to make sure that it's always in the same place. That's why I've created this second perimeter of the board outline. In my case, I select the board outline tool, and with this pen tool, the track, I can create another track like this one. You can give it the shape that you want, but make sure that this outer perimeter has the size of your PCB that you want to use, because otherwise it won't fit on side of the PCB. As you can see on this one, we have the perimeter of our board, and then we have the external perimeter, which is the perimeter that I've just created. That's very important for us to have it in order to position it when we flip the board. Another thing that you want to do is to expose the vias, because by default, if we take this all out, as you can see, these are the pads, these are the solder paste, the solder plane for all the pads that have to be removed from the solder mask. But by default, the vias, when you buy a PCB, for example from PCBWay, when you order it, the vias are not exposed. So for example, this here is a via, so you have to join the top plane with the bottom plane by hand. So in order to do that, you have to make sure that the vias is exposed, so it will remove the solder mask so you can solder then a thin wire. So what you'll have to do is to select all your vias with Control click. And when you have all the vias selected, in my case I've already done it, but let's just take this via as for example. Select this via and you click the expose copper button. You click it and then it will expose the copper. So if I remove the multi-layer, as you can see, this is the shape for the part that we need to remove from the solder mask in order for us to be able to solder it by hand. So make sure that you expose the copper on the tracks and all the other pads that don't have the copper exposed for you to later solder it by hand. Okay, and the next step is to generate the Gerber. So depending on the software that you are using, just click the generate Gerber button. In my case, I have it here, and that will download a zip file. And let's just check what we have inside of that zip file and how to use those inside of FlatCam and create our CAD files. So these are all the files that you have when you download it from your software. So as you can see, we have the drill for all the vias and all the pads, and then we have the board outline. We also have the bottom layer and the top layer. We have the silk layer for bottom and top. And what more do we have? And the top paste. And the top paste is basically what we have done for the exposed copper. And that's it. We have all the files for making our PCB. And now we should open FlatCam, which is a free software, and use it to create all the CADs for the laser engraver, and then we go to the laser engraver and make all the steps. Okay, so for the laser machine we have to create 10 files. And we create 10 files because this is a double layer PCB. For only one layer PCB, we should have maybe 7 files or something like that. And these are the files that we have to create. We have to make the bottom layer. We have to create the bottom silk layer, if you have one, the bottom solder paste, the drill file, which is the same for both sides, the outer board, and the outer cut. The outline for the board is the outline of your board, the board itself, the shape that you want for the PCB, and the outline cut is the shape for the file that I've told you, which is the file that we use for positioning the PCB when we flip it. We make the file for the top layer of the copper, the top silk layer, top silk layer SFG. Actually, these are 9 files because the silk layer will be SFG, not DXF, and also the top solder paste. And that's it. Let's see how to make this. Okay, so we open FlatCam, we go to File, Open, and Open Gerber. And here we can select the Gerbers that we want. Let's just make the top side first. So for that, I will import the Gerber for the top layer, the Gerber for the outline, the board outline, open. And as you can see, we have the outline. So first, let's just make the outline for the cut, for the positioning. So select the outline, and then you go to Properties, we go to Isolation Routing, so we just make an isolation for the laser to cut. And for the passes, in my case, I've used 5 passes and an overlap of 50%, and we create the geometry. And as you can see, this will cut the board on the outside, but also on the inside. We don't want that. So we go back to Project, we select that outline, and click Edit. And then we zoom in. We don't want to cut this board. We select these lines. Let me see if I can select them. Select it, delete it, select it, delete it, we delete it. So we delete all these lines because now we only want to cut the outside perimeter of the board, of the positioning board. So this, we only leave these lines here, so let me delete. Let me see if I can select it. Delete this one, and that's it. So now we have only the outside perimeter of the positioning outline. So now we save it, exit, and click yes to save the object. So we have our first perimeter, and now we do the same but for the board itself. So select once again the outline, go to Properties, Isolation, let's just make 5 loops of 50% overlap and create geometry. And once again, we go into Project, we select that, we click Edit, and this time we remove all the other lines. The outside lines, I'm not sure what I can select it. Anyway, this one, this one, this one, this one, and this one, this one, this one, this one, this one, and this one. And for the PCB itself, only the interior lines, we delete them and leave the outside ones. Delete this one. So now we have the outside perimeter, but also the perimeter of the PCB itself. Exit and click Save. So now we have 2 of the files, the outline of the cut itself, of the positioning board, and the outline of the board itself. Now let's just make the copper tracks of the top layer. So select the bottom layer, let's just delete it. Actually, I've imported the bottom layer instead of the top layer. So open once again, open Gerber, and open the top layer. And this will be the top layer. So once again, we select it, go to Properties, Isolation Routing. In this case, I'll make also 5 loops, but this time 60% overlap because these are the settings that I've used. Create geometry, and as you can see, this will be all the tracks. So now we have 3 files. The next file will be the top paste, I think it is. Okay, so the next file that I want to do is the drill file. So we go to File, Open, but this time instead of Gerber, I open XLN. So this will be the true hole. Yes, the true hole. So as you can see, we have all these dots. Let me just change the color to this one. Let me just make it green. So all the green points are the holes that I want to make inside of my PCB. To make the holes, instead of using the isolation tool, I will just save it as a picture in an SVG format, and then just use my software for the laser machine, the EasyCAD, and hash it, and then engrave it onto the copper. So for that, I will just go File, Export, and export as SVG, and I will save it as drill. I already have it saved here, so save it like that. Actually, I haven't showed you how to save the other files. For example, the board outline, you select it, you go to File, Export, DFX, and this will be the outline cut. Save it to outline cut, then select the other outline, File, Export, DFX, DXF, select the outline board in this case, and for the top layer, select it, go to File, Export, DXF, and this will be the top layer, and save it. And so now we have the outline of the board, the drill, and the top layer. And now we should also do the same for the silk layer, so just open it, open Gerber, and this will be the top silk layer, this one here. And the top silk layer is this one, and for this we will also save it as a picture, so just go to File, Export, SVG, and save it as top silk layer SVG. But you don't have to place SVG. That's just because I've made tests with isolation routing and also SVG, and with SVG you get better results because you also have the feel of the letters, not only the perimeter. So now we should have all the files for the top layer. Now let's just make the bottom layer. So let me just delete the top layer here, the top silk layer, and the drill is the same, so we can delete it. And then all the files that we have created, we delete those as well. And now import file, import, open, Gerber, and bottom layer. Once again, we select it, properties, isolation routing. It was 5 and 60. Create the geometry. Now go to project, click that the geometry, file, export, DXF, and you save it to the bottom layer, which is this one here. You save it. Now we can delete it. We can now import, open another Gerber, and this will be the bottom paste, which will be top, bottom, silk layer, bottom solder mask is this one. And this, once again, you select it directly, you don't have to make an isolation routing, export, and export it as FVG, and this will be the bottom solder paste. Save it here. We can now delete it, delete this as well. We can now import the final part, open, and this will be a Gerber, and it will be the bottom silk layer. Bottom silk layer, this one here. Select it, file, export, SVG, and save it to bottom silk layer. And that's it. We have all the files. We have the perimeter of the PCB, the perimeter of all the tracks. We have the file for the top layer paste, bottom layer paste, and also the silk layer. And now we can go to EasyCAD and create the files for the laser machine. Okay, so in EasyCAD, first you can download these files, which I've downloaded for YouTube channel, that you will have it below. And these are for the files for hatching, for frequency versus power and speed versus power, and just open it up, select everything with this button, center it, and then with your machine test it on your copper or on your solder paste. Once you've made the test, you can write it down and they make the test for your files. So now let's just go to our files that we have just created in FlatCam and see how to print them on the machine. So in this software, before I import all the files, as you can see here on the side, we can change the speed, we can change the power, and also the frequency. And if you click this button here, you can understand more or less what the frequency is. Actually, the more speed you have, as you can see, imagine that this circle here is the dot of your laser, and this is a pulse laser, so it will make pulses. So the higher is the frequency, the more merged together are the dots, and also the higher is the speed, more space it will be in between because they go very fast. So you can play around with the speed and the frequency, but have in mind that if you have the dots very close together, the power, which can be up to 100%, will be divided into all those spots. So you don't make 100% power for each spot, but you can divide it between all of them. So having the spots not that close together actually will cut a lot more the copper tracks than having them merged together, because if they are one on top of the other, they divide the power and it will be less power but more frequent. So it will just polish the copper instead of cutting it. But if you have it divided with very much space in between, it will have all the power into just one spot, and it will be more abrasive, more aggressive to the copper, and it will cut it. So in my case, for the frequency, I've set it to 37 kilohertz, and then just change the power from 100% to any other value. And for the speed, usually the maximum that I've used is 200 millimeters per second, but this will change for each file. So the first file that we have to make is to make the outline of the PCB. Remember, we have to make the cutout of the PCB. That's the first part that we will make. So for that, in EasyCAD, you just go to File, Import Vector File, and let's just go to the files that I've just created for my Arduino Uno, the CAD files. And remember, we had 10 files. In this case, I will import the outline cut. We have it here. And just import the top layer as well, because we will use it. Top layer. Import also the drill, because we will use it. Import also the top solder paste. Top solder paste. And now just, yes, this is everything that we need for the first test. Click the select all button and then place it in the middle. Don't place the files in the middle one by one, because those will move by themselves with a different origin, so then it won't be one on top of the other. So make sure that you select all the parts, which are 4 in this case, and then you center it, so you will have all the parts aligned. So now the first one that you want to make sure is that you click this check here to mark only the selected part, because otherwise it will print them all at the same time. So now, since you want to cut the exterior of the PCB, select the outline cut, and for me it was, let me just bring the paper. Okay, I have all my data here. So for cutting the outline, it was 30%, and the power 100%, 37, and for the loops, I've made 3 loops. And have in mind that this is 5 loops of the design and 3 loops of the software itself, so a total of 15 loops, and it will take like 1 minute. So cut the outline of the board, and then we go to the next step. So you get your copper board, you fit it in place, you mark the outline, and then you glue it with some scotch tape, and then you cut the positioning outline of the board. That's the first step. Now let's go to the next step. Then you have to remove the board and clean it a little bit, because it will be filled with small copper dust and also some debris, any kind of debris from the board itself. I took some very fine cardboard, stick it in place onto the machine with some scotch tape, and make the same shape, the same cutout with the outside perimeter. And once I have that cutout from the cardboard, I can place my PCB inside, and I will make sure that it will always be centered with the rest of the design. So for the next step, place the board that you have just cut it inside of the cardboard, and you engrave the top layer of the tracks. And for that, I've used, in my case, 150 millimeters per second and 100% power. And no, I had 5 loops and 95% power, and the speed was 160 millimeters per second. Okay, so take the PCB that you have just cut it, place it inside of the cardboard that you have just cut it as well, so it will be centered. And now you can make the top layer of the tracks. So for that, in EasyCAD, select the top layer, and for the speed, for the loops, I placed just 1. For the speed, I've made 160 millimeters per second, and for the power, I've made 95%. And frequency is the same. So now you engrave the tracks. Once you have the tracks, you can remove the board, clean it with some alcohol and with some toothbrush, because some small bits of copper will be stuck inside of those tracks, and they will make a short circuit. Actually, in this case, I've also took a multimeter and test one by one the pads and make sure that there is no short circuits. And actually, I had some short circuits with some small dots of copper that were sticking inside of the tracks. So clean it well with a toothbrush and with some alcohol, and make sure that you have no short circuits between the pads and the tracks. Oh, and by the way, if you have some sort of air blower with a lot of pressure, just blow it a little bit and make sure that you clean it even better than with the toothbrush. Now in my case, for the first test, which was the green PCB, I've already made the drills, but then I've told you that first you should apply the solder mask, remove the solder mask with the laser, and then make the drills. So you should follow the second attempt. So in this case, it will be to just apply the solder mask. So once you have the tracks for the top layer, apply the solder mask and then leave it below the UV light for like half an hour to make sure that it's dry. And then you take the PCB and place it back inside of the cutout that we have made with the cardboard. And then you can remove the solder paste. So for that, just select the solder paste, and here we have to make something which is called hatch, because the solder paste for now is not a DXF file, it's just a picture. So for that, you go to this H here, which is hatch, we click it, and since I want to remove pads, what I will do for the type, instead of zigzag, I will make it like a tornado, like in circles. So select this type, and for the line space, just place 0.04, and it will be good. Place OK, and as you can see, that will create the hatch for all the pads that we want to remove. Now for the power, for speed is 100 millimeters per second, and the power only 25. Because if you remember, if you take this graph here, you can know the power that you have to place in order to not remove the copper but only the solder mask. So apply this, remove the solder mask from the pads, and then you can pass to the next step. And the next step is to make the drill, and in the same way select the drill file. Once again, you go to hatch, because this drill file is also just a picture, and place the same settings as for the solder mask. But now for the power and speed, we have to change that. Actually, to make the drill, you have to pass a few times. The first time I've passed with 150 millimeters per second, and the power of only 75. Why we do that? Because we want the first layer to be a very soft cut, so the edge of the holes will be perfect. Otherwise, it will be so brutal and so powerful against the copper that the hole won't be perfect. It will be like with some sort of error. So we passed with 150 meters per second and 75% power 2 times. And then we make 5 more times with 150 meters per second and 85% power, and that should cut the board pretty much halfway. And then we can flip it and cut it on the other side. But that will be the next step. By the way, to apply the solder mask, I'm using this kind of mesh. This costs just a few dollars on AliExpress. And then I've printed this circle with my 3D printer. And as you can see, you can separate it. You place the mesh in between, you make sure that you tighten it. And also if you heat it up, it will be very, very tight. And then just apply the solder mask. Actually, the first solder mask that I applied for the first prototype ever, which is this one, was with just my hand and a piece of very tiny plastic foil. And this wasn't very good because it's not very well proportional, it's not spread very well on the PCB. That's why I've used this plastic mesh, and as you can see, the solder layer, the solder mask is well spread on the entire PCB. So apply it, cure it with UV light, and then remove it with the laser. Have in mind that for each color, the exposure time for the UV light will be different. White is just 5 minutes, but the rest could get up to 25 or even half an hour. Okay, so it's time to flip the board so we can delete all these files from EasyCAD. So actually just make a new file, new, and now import the bottom files. But once again, import the cutout of the board. We also import the cutout of the board itself, not for the positioning. We also import the bottom layer for the copper, and that will be the bottom solder paste, no, the bottom layer. We also import once again the drill, because we have to drill it from the bottom side as well, the drill. And we also import the bottom silk solder paste. Bottom solder paste and the silk layer if you want, but in this case I don't want it. So select all the files, center them, and now what you have to do is to just take your PCB and flip it. In my case, let's just say that we flip it like this, which is horizontally. So make sure that you now select all the files and click this button here, which is flip it horizontally, mirror X. If you mirror it on the Y direction, make sure that you click the mirror Y button. But in this case, if you flip it like this, I will click this button here, and now the entire design is flipped. So once again, select only the cut for the board, For the positioning board, engrave it onto a cardboard, take out the cardboard, so now you can place your PCB inside of that cutout. Place the PCB and now we make the same processes. First we cut the bottom layer, select it, and use the power that I've gave you, which was 150 meters per second and 100% power. So do that, then you apply the solder paste. Once again, select the solder paste here, which is this one. You go to hatch, place it like this, round 0.04, okay. And now you can engrave this and remove the solder paste using 23% power. And then you can make the drill. But this time you make the same process, 150 meters per second, 75% power. And you do that a few times till you go and you merge with the other holes from the other side. And now you have the solder paste removed, the drills and everything done. And then the final step will be to cut the outside to the perimeter of the board. By the way, between these steps you should remove the board, clean it, and also test it once again with the multimeter and make sure that there are no small dusts of copper in between the tracks, because that will be a short circuit. And then you apply the solder paste and remove it and make the drills. And finally, select the board outline, which will be outline board. We go to power, and for cutting the board I've used, so for that, for the power we will place 30 millimeters per second, 100% power, 37 kilohertz, and for loops we'll place 3. And that will cut the board out and you will get your final PCB. That's it, 13 steps, and these are the files, and this is how you should prepare the files in your EasyCAD software. Pretty easy, right? If you have this right down and you have all the settings and you have everything prepared, you can make your PCB in like 7 or 8 minutes without exposing the solder mask. So guys, we went from this to this. Now we have our PCB. But is this done? Is this a perfect PCB? Well, not yet. We still have two problems that we have to manage. First of all, the vias. You see, you have a few vias. I think this has 5 or 6 vias, and we need to merge the top layer with the bottom layer. And to do that, I bought some rivets, but I don't like those because they are too big, and I haven't found rivets with 0.4, 0.3 millimeters in diameter, so I won't be using that. I think it's even easier to just use some solid wire. You cut the wire to size, you put the PCB in midair with some support, you fit the wire in each hole, and then you use your soldering iron to merge the top part with the bottom part, and then you cut the wire, and that's it. You have your vias merged together. But then the other problem is how to merge the pads of the components, because there are some components that have a connection on the top layer but also on the bottom layer. For example, with a MOSFET you can just fit it, solder it on the top and on the bottom because it has very fine legs. But for example, for the female pins you can solder below the pins, so that will be a problem. So maybe in that case you could use the rivets, because the advantage with using this kind of rivets that I will place on the screen is that when you hammer it in place, you merge the top layer with the bottom layer, but you still have the hole, so you can use those rivets to maybe place the components. But for that, unfortunately, I will have to make the board once again, because the holes that I've drilled with my laser machine are too small for that. So I will have to make the small bigger in the design, having in mind that I will use 0.6 millimeter rivets. So that's why I haven't done that. But doing that, you will have a finished PCB in just 10 or maybe 15 minutes, made at home. It looks a bit professional because it has the solder mask and so on, and that's it. That's it for this tutorial. And I know this was a little bit long because now I'm making this kind of videos, but I wanted to pass through all the steps, how to make the tests, how to write down the results, and then make the first PCB, the second PCB, and how to improve it. I will make another PCB for a future project, and that will be even better because I still have some errors that I've made, and I want to correct that and make them in the third PCB that I'll make. Because for now I've made the green one, which actually I've made 3 PCBs, but this one was a fail because the power for the pads was too much. Let me just focus here, and as you can see, it basically removed the pads. But then I've made this PCB, which is for a future project related with plasma and sound. You will see it. I've made this PCB here and also this PCB here, which is just an Arduino Uno. And this is the second attempt, and it turned out a lot better. And for the next one, I will also want to make the silk layer with double color and so on, and also find a solution for merging the top layer with the bottom layer for the vias and the pads. Maybe even tin plating the PCB. But I can't do it now, so it will be for a future video. And that being said, I hope that you have learned something new. I hope that you liked this video, and if so, give me a like or maybe comment below. Thanks again, and keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.